It is the 21st of July, 1938. The head of the Nazi SS, Heinrich Himmler, is writing a letter to Reinhard Heydrich, head of Reich Security Services. Himmler is concerned. He has learned about developments in the investigation of a top German scientist, one who is suspected of being critical of the Nazi oppression of the country's Jewish community. Himmler is direct in his letter to Heydrich. The investigation is to be dropped. The scientist is too valuable to the regime and could prove to be a critical figure in the Nazi goal of developing new superweapons. He will be needed when the coming Nazi war of revenge across Europe is launched, and is the man the Nazis believe could be pivotal in building the world's first nuclear weapon. The scientist's name? Werner Heisenberg, the man behind the Nazi nuclear weapons program. The man known to history as Werner Heisenberg was born on the 5th of December 1901 in the city of Würzburg in the Bavaria region of southern Germany. His full name was Werner Karl Heisenberg. Werner's father was Caspar Ernst Heisenberg. He was a leading Greek scholar of the Byzantine Empire, the Eastern Roman Empire that had survived the fall of the Roman Empire. The Byzantine Empire had ruled over vast swathes of the Eastern Mediterranean and had continued down to the final conquest of Constantinople by the Ottoman Turks in 1453. Caspar had travelled widely around the Mediterranean, carrying out archaeological surveys, as well as dealing with written sources. Multilingual in German, Greek, Latin and other languages, he had, by the time Werner was born, obtained a teaching position in Würzburg. He would later become a professor of Byzantine studies in Munich. Werner's mother was Annie Wecklein. Werner was the second of their children. Another boy, named Erwin, was born in 1900. Werner was born as the German Empire was starting to emerge as the dominant continental power of Europe. There had never been a fully unified German state prior to 1871. Germania had been recognized as a broad geographical entity by the Romans. This was synonymous with the lands stretching from around the River Rhine in the west all the way east towards the River Oder, and beyond into what the Romans called Polonia, modern-day Poland. In medieval times, this region was unified to some extent under the aegis of the Holy Roman Empire. However, this was a very loose federal union of hundreds of duchies, baronies, margravates, and even small imperial cities and counties. A process of consolidation began in the 16th century, and by the 19th century, partly through the impact of the Napoleonic Wars, the hundreds of German states had been reduced to a few dozen larger ones. The largest of these was Prussia, with others including Bavaria, Baden, and Hanover. In 1871, the largest of the North German states, Prussia, succeeded in uniting the German states into a German empire at the end of the Franco-Prussian War. By that time, the Industrial Revolution was already transforming German society. This was particularly the case in the Rhineland region, where the key resources needed for industrialization in those days, coal, iron and rivers to transport them along, were in great abundance. Thus, Germany grew and grew, so much so that by the time Werner was born in 1901, the Germans were attempting to compete with the British Empire for preeminence in the world order. German colonies had been acquired in Africa and Asia, and a foolhardy naval arms race had been entered into with the British. This conflict with Britain and Germany's attempts to establish itself as the dominant power on the European continent would shape Werner's life to an extent. He carried out his work in the shadow of war, political change, and the seemingly endless ideological twists and turns which were to take place within his native country. Britain was the great imperial power of the day, ruling an empire that stretched from the islands of the Pacific to Hong Kong, Singapore, India, and across much of Africa. However, it was not the intellectual center of European civilization at the dawn of the 20th century. Certainly, every major European country had contributed to the continent's culture and understanding of science over the centuries. Isaac Newton had revolutionized the early understanding of physics and mechanics from England. Galileo had come from Italy, Copernicus from Poland, and Voltaire, the giant of the Enlightenment, had hailed from France. Even in the 19th century, literature was spread fairly evenly around the continent. For every Dickens in England, there was a Victor Hugo or Émile Zola in France, or a Fyodor Dostoevsky in Russia. The cutting edge of scientific development in Europe in the late 19th and early 20th centuries was in the realm of physics. Most of the important breakthroughs in this field were being made in universities across Germany and lands very nearby in Austria, Switzerland, and Denmark. Albert Einstein might have been working as a patent clerk in Switzerland in 1905 when he submitted a series of papers which changed our understanding of the world. But he was a German. Max Planck, another major figure in the development of modern physics, came from northern Germany and carried out his groundbreaking work while at the University of Berlin. Nearly half the Nobel laureates for physics between 1901 and 1940 were Germans, or people associated with German universities in some way. If Heisenberg was going to go on and make a major impact in the world of physics one day, he was certainly born in the right country. Heisenberg grew up in a scholarly upper-middle-class family, and there was never any doubt about him being afforded a very good education. His family life was well off by the standards of early 20th century Germany. He was sent to a primary school in Würzburg in September 1906, shortly before he turned 5. Werner's elementary schooling here was cut short after his father was appointed as the new professor of Greek and Byzantine studies at the University of Munich, and the family relocated to Bavaria in southern Germany. There, Werner was sent to attend the Elisabethenschule from September 1909 for 1 year to complete his primary education. Then, it was off to the Maximiliansgymnasium, an elite school in Munich that had been founded by King Maximilian II of Bavaria in 1849. Heisenberg grew up continuing to adhere to the evangelical Lutheranism in which he was raised. His Christian belief would always have a rational element to it. Heisenberg believed in the moral and spiritual tenets of Christianity, while at the same time he dismissed the biblical tales of miracles and the supernatural as superstition. Heisenberg's decision to become a physicist was, he later claimed, owing to his family's roots in studying ancient Greek culture and philosophy. This was not as peculiar as it seems. The earliest Greek philosophers of the 6th and 5th centuries BC considered philosophy, and what we now term physics, to be intrinsically connected. Understanding a person's morality and place in the world was closely associated with understanding the nature of the universe. Indeed, it was these Greek philosophers who first proposed that the world and universe were made up of tiny building blocks which could not be seen by the naked eye. They called these atomos, from which the modern word atom derives. Heisenberg's interest in physics, accordingly, grew out of reading the works of the earliest Greek philosophers and their pioneering work in physics. Werner was just 12 years old when the First World War broke out over the course of a week in the final days of July and the start of August 1914. He was consequently too young to have played a role in the conflict which ended in November 1918. At this time, Werner was still shy of his 17th birthday. Like all German teenagers, He would have been acutely aware of the dwindling supplies throughout the country. Rationing was underway throughout the war, but strict ration books on basic commodities like butter and sugar were in place in the final months of the conflict. The German Empire collapsed as the war ended and was replaced by a republic. However, it had only a tenuous control over the country. Uprisings to try and establish regional communist governments across Germany flared in Berlin, Munich, and other locations. Despite his youth, Werner was one of hundreds of thousands of German men who joined the Freikorps in 1919. These were units of irregular troops deployed by the government to suppress the unrest. It was the beginning of his lifelong antipathy towards communism. He does not appear to have been active with the Freikorps in any military sense. As a young man with no experience of fighting in the war, he was confined to administrative duties and monitoring prisoners. A year later, in 1920, Heisenberg began studying at the University of Munich. There he studied under the theoretical physicist Arnold Sommerfeld. Sommerfeld is not as well known as many other theoretical physicists today. This should not detract from his accomplishments. He was a pioneer in the field, born in 1868, and he went on to act as a doctoral supervisor to 7 Nobel laureates, including Heisenberg. Werner studied under him at Munich and also spent time at the University of Göttingen, where he was influenced by the mathematician David Hilbert and another theoretical physicist, Max Born. In 1923, at just 21 years of age, Heisenberg completed his doctoral thesis under Sommerfeld's supervision. In translation, it was entitled On the Stability and Turbulence of Liquid Currents, and consisted of a 59-page study of laminar flow in liquids. As soon as he completed his doctoral studies, Heisenberg headed for Göttingen to undertake his habilitation. This is a further award, again beyond the doctorate which exists in many continental European countries, especially in German universities, and is considered a kind of masterwork beyond the doctoral degree. Heisenberg completed his on the Zeeman effect. It had been discovered back in 1896 by a Dutch physicist named Peter Zeeman. The effect is best described where spectral lines split into different components after coming into contact with a static magnetic field. The Zeeman effect was not entirely understood by the 1920s, and Heisenberg completed work on the more anomalous elements of it for his habilitation. His move to Göttingen also provided him with a temporary teaching role, though there was never any doubt that he would have found a lecturing and research position somewhere. Heisenberg was already emerging, after all, as one of the most promising physicists in the world, a young man who had acquired his doctorate and habilitation before reaching his 23rd birthday. And yet, he was not occupied by his research 24 hours a day, 7 days a week. Away from the lab and the university, he was a keen musician and played classical piano. Heisenberg also liked skiing and spent holidays in the Alps. He had numerous friends in the academic world, though he was known for being fairly formal in his interactions, something which perhaps explains why he did not marry until his mid-30s, which was considered very late in life to do so in the first half of the 20th century. Heisenberg had a junior position at the University of Göttingen from 1924 onwards. However, he spent much of his time in the mid-1920s travelling. He spent the fall term of 1924 and the spring term of 1925 as a visiting fellow of the University of Copenhagen in Denmark. This was one of the most important periods of his life, both in terms of the work he carried out during this time and the intellectual and personal friendship he developed with Niels Bohr, who was also working in the Danish capital. Bohr was in his late 30s by then, and was already well established as a leading figure in the emerging field of quantum physics. He had won the Nobel Prize in physics in 1922 for his work on the structure of atoms and other elements of quantum physics. Under Bohr's influence, Heisenberg began focusing to a much greater extent in his research on the cutting edge of quantum physics. While working with Bohr in Copenhagen, Heisenberg laid out the groundwork for a new, influential theory in the world of physics. This was the theory of matrix mechanics, which Heisenberg would develop further when he returned to Germany later in 1925. He published his findings that autumn in a paper which, in translation, was called Quantum Theoretical Reinterpretation of Kinematic and Mechanical Relations. It would form the basis for the rapid acceleration in understanding of quantum physics in the years that followed. On the back of it, Heisenberg suddenly became regarded as an emerging giant of European science, a figure who, in his mid-20s, was transforming the field of quantum mechanics. His achievements around 1925 were not quite on the same level as the Annus Mirabilis of Isaac Newton in 1666, or those of Albert Einstein in 1905, but they weren't too far away at the same time. What exactly was matrix mechanics? And why was Heisenberg's work on it, while in Copenhagen in 1924 and 1925, so important? Matrix mechanics is a theory for how quantum mechanics function. Quantum mechanics is a subfield of quantum physics, which seeks to explore how and why matter, light, and other things on the quantum level of the physical universe behave in the way that they do. Huge amounts of this field of study were emerging in the 1920s, as new research was published by scientists, usually working in Central European universities in Germany, Denmark, Switzerland, and so forth. For instance, photons, the quantum unit of light, which are integral to the study of quantum mechanics, had only first been theorized by Albert Einstein in 1905. Moreover, in those days, it took time for new research to be disseminated. This was down to the fact that research was published in hard-copy academic journals, and as a result, it might be years before a fellow physicist came across a new academic paper or idea. Therefore, Heisenberg was working at the very frontier of physics in the mid-1920s. Heisenberg's matrix mechanics argued that physicists needed to move away from studying particles in classic ways, such as focusing on their trajectories. Instead, Heisenberg advocated that the physicist should focus on a matrix of mechanics which surrounded each particle. This would give a better understanding of a particle's energy levels or the different ways in which they could transition. What Heisenberg was proposing was that, in studying quantum mechanics, it was not sufficient to adopt a traditional approach and that a whole matrix of mechanical impulses would have to be considered. As this theory was gradually proven to be correct by other physicists during the second half of the 1920s, it was determined that Heisenberg had helped revolutionize our understanding of the microscopic world. No longer could physicists look at subatomic particles and expect them to behave in a predetermined way. Instead, they would have to bear in mind that a whole matrix of possibilities and behaviors were in play. This would be one of Werner's great contributions to the history of science. It led to a major expansion of study in the field of quantum mechanics across Europe from 1925 onwards. In the mid-1920s, Heisenberg began work on a theory which would become his defining piece of research, what is known as the uncertainty principle. This was very closely related to his work on matrix mechanics. To fully grasp what the uncertainty principle is, we need to understand the difference between classical physics and quantum mechanics. Classical physics supposes that exact values can be assigned to physical objects and quantities within the universe. So, for example, an atom can be examined and quantified in an explicit way, as can the number of electrons, photons, and the like within specific atoms. For instance, atoms tend to have 8 electrons within their valence shell. A a phenomenon known as the octet rule. This also manifests in things that can be seen and examined with the naked eye, and by regular people going about their day. If a car is at a certain point on a straight highway with no turns and is traveling at a steady pace of 60 miles per hour, you can predict that it will be about 10 miles further along on the highway 10 minutes from now. As quantum mechanics developed in the early 20th century, it became evident that these rules of classical physics were far less tidy than had previously been thought. Physicists began to notice that on the quantum level, these same rules did not apply, and things behaved, for want of a better word, irrationally. Heisenberg began studying this phenomenon in a more systematic way in the mid-1920s. What he concluded after a considerable amount of research was that even if the position of a particle can be concretely established, there is no way of predicting what its momentum will be. In fact, in quantum mechanics, the more precisely the position is known, the more difficult it is to predict momentum. So, if the car on the highway existed within quantum mechanics, not only might it not show up 10 minutes later, 10 miles further along the highway, it might have actually decided to take off instead in another direction at a completely different speed. This realization of Heisenberg's, that things do not behave in a predictable manner within quantum mechanics, is typically referred to as the uncertainty principle. However, the German term he was concerned with was Anschaulichkeit. This word doesn't have an exact English equivalent. It means something quite close to unintuitive. Heisenberg developed the uncertainty principle through numerous experiments, notably by studying electrons and the light waves emitted from them, dependent on their position. It was through tests like these that he was able to demonstrate the irregularities of movement and action which characterized physical things on the quantum level. The question arises, though, beyond demonstrating that things do not behave in a certain manner on the quantum level, what practical applications did the uncertainty principle have? While it did not have any implication for the average German person in the 1920s, once Heisenberg published his research, it fundamentally changed how theoretical physicists carried out their work from 1927 onwards. Prior to this, many physicists had been operating under the idea that, as their equipment improved and their understanding of quantum mechanics expanded, they should be able to come up with ever more accurate and predictable models for how the world operated on the quantum level. Heisenberg's uncertainty principle changed this. Now, theoretical physicists and those working on quantum mechanics knew that they could not always expect electrons, or whatever else they were studying, to behave in a completely predictable fashion. There would always be uncertainty involved in examining the universe on the quantum level. Heisenberg formulated the uncertainty principle just as the entire field of study of quantum mechanics was taking off. It was chosen as the topic of the 5th Solvay Conference, which was held in the late autumn of 1927. The Solvay Conferences are scientific conferences which were founded by the Belgian businessman Ernest Solvay in the early 20th century. Solvay was a wealthy industrialist who had made his money from producing industrial chemicals in plants which he first established in his native country in the 1860s, expanding his operations to countries like Britain, France, Russia, and the United States as his enterprises grew. Following the example of the leading titans of business around the turn of the century, he engaged in extensive philanthropy. An element of this was his financing of the Solvay conferences in Brussels. Here, leading scientists were brought together to work on problems and cutting-edge research in the fields of physics and chemistry. The first Solvay conference was held in 1911. Heisenberg was invited to the 5th conference, held in the Belgian capital between the 24th and 29th of October 1927. The focus was on electrons, photons, and the emergent field of quantum mechanics and theory. Albert Einstein, Max Planck, Niels Bohr, Max Born, Erwin Schrödinger, Marie Curie, and Paul Dirac were also in attendance. 17 of the 29 attendees were Nobel Prize winners. Marie Curie had even won two, one for physics in 1903 and one in chemistry in 1911. There have been few gatherings as impressive in history, and a group photo of the attendees has been termed the most intelligent photo ever taken. Over the space of a week, the new field of quantum theory was discussed at length. Problems were identified along with possible research approaches, and the whole conference gave new direction and purpose to the emerging area of quantum mechanics. The Solvay conference could not have happened at a better time for Heisenberg. He was very much a junior figure at it, but nobody could have doubted that his research on matrix mechanics and establishment of the uncertainty principle had put him at the forefront of the field. When he returned to Germany, his career began to take off in new ways. He was appointed as the youngest ever professor of theoretical physics at the University of Leipzig. There, he began work on the basics of quantum field theory. The research center that he ran at Leipzig also became a magnet for many of the most promising young researchers of the day from all over the world. Visitors included Robert Oppenheimer, who was just a few years younger than Heisenberg, and Edward Teller, a brilliant young physicist who had transferred from the University of Munich to Leipzig in 1929. Teller now studied under Heisenberg and obtained his PhD a year later at 22 years of age. Oppenheimer would go on to lead the Manhattan Project, the US program that successfully developed the first nuclear weapon during the Second World War. Teller was also a key figure in the Manhattan Project and played a significant role in the subsequent development of the more powerful hydrogen bomb. What all of this indicates is that Heisenberg and his research team at Leipzig had become the epicenter of the global study of quantum mechanics and theoretical physics. Heisenberg also went on lengthy lecturing tours, traveling to the US, Japan, and other countries. By then, though not yet 30 years of age, Heisenberg had been nominated for the Nobel Prize in Physics by none other than Albert Einstein. He was eventually awarded the honor in 1933, though retrospectively for 1932, a year in which the prize had not otherwise been awarded. By the time Heisenberg was awarded the Nobel Prize for what the Academy termed, quote, the creation of quantum mechanics, the application of which has, inter alia, led to the discovery of the allotropic forms of hydrogen, political change was sweeping through his native country. As a leading scientist, Heisenberg had been insulated economically from the Great Depression that swept across Europe and the Americas in the 1930s after the Wall Street crash of October 1929. However, his fellow Germans had felt it. Millions lost their jobs, their savings, and their sense of pride. A radical political party, Adolf Hitler's Nazis, had risen to become the most popular party in Germany, offering to restore Germany to its former greatness. Enough people were convinced by their message of radical nationalism and xenophobic hatred that they acquired roughly a third of the vote in two different elections in 1932. By early 1933, the centre-right establishment had agreed to Hitler becoming Chancellor of Germany. The Nazis quickly turned Germany into a one-party fascist state. Overnight, every academic and scientist in Germany was placed in a difficult position as the Nazis began to interfere in the intellectual independence of the country's universities. Book burnings were underway by the summer of 1933, and investigations into the potential Jewish heritage of lecturers and professors were being carried out. Despite the fact that he did not have any Jewish ancestry to speak of, Heisenberg was suspected of being partly Jewish by Heinrich Himmler, the head of the SS, the Nazi paramilitary organization that would later run the concentration camp system across Europe. This suspicion stymied Heisenberg's career advancement in the process and points towards the fact that he was hardly any kind of enthusiastic supporter of Nazism from their earliest days in power. The Nazi hostility towards Heisenberg cooled eventually. There were multiple reasons for this. Firstly, even by the bizarre rules which the Nazis employed to establish the potential Jewish heritage of an individual, it became clear that Werner was not Jewish. As a result, he would not be prosecuted under the Nuremberg laws of 1935, which were essentially turning the German Jews into second-class citizens. Secondly, Heisenberg's mother was an acquaintance of the mother of Heinrich Himmler, the head of the SS, and the two mothers sat down to resolve the differences between their boys. The fascist government was also wary of a brain drain as leading scientists left the country for Britain, France, Austria, and the United States. It seemed that the Nazis did not want Heisenberg to join this exodus. In 1938, Heisenberg's career picked up, and he was soon being promoted again. In the interim, he had continued to publish. His latest research in the mid-1930s was on cosmic ray showers, through which astroparticles traveled through space at speeds approaching the speed of light. It is hard to assess his wider beliefs during this era. Heisenberg was not a Nazi. However, he was a staunch German nationalist and did believe in the idea of German revival after the humiliation of the First World War. He also loathed communism since the days of the German Revolution after the First World War. He viewed elements of the Western democracies as offering weak leadership compared with the authoritarian governments that had claimed power all over Central Europe. In short, Heisenberg can't be identified as a Nazi, yet his politics were controversial all the same, albeit reflective of many other Germans in the 1930s. As we have seen, as well as his work in theoretical physics and his interest in philosophy and the Greek classics, Werner's other major hobby was playing music. This was how he met his wife and started a family. On the 28th of January 1937, Heisenberg met up with some musician friends in Leipzig, with whom he played the piano regularly. A violinist friend had brought along a young woman that evening by the name of Elisabeth Schumacher. There was a considerable enough age difference between them. Werner was 35 years old by then, whereas Elisabeth was just 21. He was smitten with her, and she was seemingly impressed by his piano skills and his intellect. 2 weeks later, he proposed to her, and Elisabeth accepted. The day after his proposal, Werner wrote to his mother with the good news in a way which explained how they had immediately clicked. This mutual understanding, in which one, as it were, only needed to continue a conversation begun a long time ago, soon went so deep that it seemed natural to me to ask Elisabeth whether she would like to be with me forever. They married on the 29th of April, 3 months after their initial meeting. They would go on to have 7 children together. They also maintained a remarkable correspondence for a period of more than 9 years. This began right after they met and continued down to 1946. There were numerous reasons why they continued writing to each other. Sometimes they were separated for periods of time because of Werner's work. After the war, it was because Heisenberg was imprisoned for a while. Evidently, Werner deeply loved his wife. An example of this affection can be found in a letter which begins, "My dear sweet Lee, how much beauty the past year has brought me through you. And yet, everything up to now strikes me as a mere beginning, only to be followed by even more beauty and togetherness." Thus, while the rise to power of the Nazis created difficulties for Heisenberg initially in the 1930s, his home life appeared to be very happy in this period, even as he married comparatively late in life. Heisenberg's relationship with the Nazi regime up until the end of the 1930s was distant for the most part. Early on, he had fallen under suspicion of being either partly Jewish or of entertaining Jewish sympathies. These suspicions passed after a time, and he simply managed to live under Nazi rule. It must be remembered that the German view, and even the international view, of Hitler's National Socialism during these years was very different to what it is today. British and French politicians expressed some concern that Germany was rearming, which was in breach of the Treaty of Versailles that had concluded the First World War. However, others were impressed with the way that the Nazis seemed to have rejuvenated Germany's economy. They had seemingly pulled a country that had been hit very hard by the Great Depression out of an economic quagmire, creating millions of jobs through large government-backed infrastructure projects. British politicians, as esteemed as the former Prime Minister David Lloyd George, visited the country and remarked favourably on how things were being run there. Others perceived the fascist system as being a necessary bulwark against the rise of communism. For figures like Heisenberg, there might have been some dismay about Nazi interference in the country's universities and the persecution of the country's Jewish population of 500,000. However, lacking the awareness of the crimes which lay ahead, many people learned to live aloof from the regime. For a figure like Heisenberg, a German nationalist, though no Nazi, he simply acclimatized to life under Nazi rule. When the country dragged Europe to war in September 1939, invading Poland after already annexing Austria and Czechoslovakia in March 1938 and March 1939, this seemed as simply the latest development in the continent's perpetual conflicts over the centuries. This is how Heisenberg might have rationalized his actions both during and after the war. However, the reality was different. From its very inception, Heisenberg was involved in the war effort in a very significant way. The major powers in the conflict were aware from the outset that, owing to the advances in physics since the 1920s, it was theoretically possible to build a nuclear weapon. There were major hurdles to overcome at the same time, particularly the issue of how to enrich uranium to make such a weapon. Before the war had even started, the Nazis had set up a working group known as the Uranverein in the late spring of 1939. Uranverein meant Uranium Club. These efforts gathered momentum as the war broke out in September 1939. Heisenberg was asked to attend one of the first ever meetings of the Uranverein and accepted. Later he claimed he only participated because he viewed it as being impossible for Germany to develop such a weapon, at least not without years of work and the investment of an awful lot of resources. These resources were of the kind which the precariously balanced German war economy could not spare. Try as he might, though, to give the impression after the war that he tried to delay the project, the evidence is clear that Heisenberg was involved in the German nuclear weapons program throughout the war. Heisenberg was primarily involved in the development of a nuclear reactor. He played a very small role in the program to develop a weapon using a substance called heavy water, which was underway in Nazi-occupied Norway. It is obvious from reading Heisenberg's notes throughout the war that he believed Germany could never enrich the quantity of uranium needed to come up with a working nuclear weapon. While Heisenberg's role in the German nuclear program is complicated, and his own justification for his involvement is hard to decipher, there is no denying that it had personal consequences. Back in the 1920s, despite their age difference and different personalities, Heisenberg had become good friends with Niels Bohr. They collaborated in their research through the 1930s and remained close. The outbreak of the war certainly created difficulties. Germany invaded and occupied Denmark swiftly in April 1940, as it ratcheted up the war in preparation for the invasion of Western Europe in May, creating tensions between Bohr and Heisenberg. Bohr's country was now under occupation by a government which Heisenberg continued to work for, even as some German scientists had fled overseas to Britain or the United States. It was in this grim context that Heisenberg visited Copenhagen in September 1941 to meet with his old friend. This was the peak of Germany's war fortunes. Western Europe was conquered. The US had not yet entered the war, and the German Wehrmacht was winning victory after victory on the Eastern Front after invading the Soviet Union at the end of June. For instance, as Heisenberg made his way to the Danish capital, the Germans were preparing to capture the Ukrainian capital Kyiv. In this context, Heisenberg possibly hoped to convince Bohr that German victory in the war was inevitable and that he should join the German nuclear program. At a certain point during his visit, Bohr and Heisenberg headed off to converse alone. Exactly what they discussed has been widely debated. Bohr later claimed that Heisenberg tried to convince him to join the Nazi program, whereas Heisenberg argued that he wanted to simply discuss the theoretical difficulties of enriching uranium and how he believed it would not be possible for the Nazis to do so. Whatever was actually said, we know what the result was. Bohr and Heisenberg fell out dramatically, and their friendship never recovered. Heisenberg's involvement with the Nazi nuclear program was all in vain, whatever his actual motives were. In the weeks that followed his visit to Copenhagen, German success in the war changed very quickly. As the Germans and their Italian, Hungarian and Romanian allies advanced further and further into the USSR, their supply lines became overextended and their men simply became tired. Conversely, the Red Army began to fight back. The goal of taking Moscow and Leningrad before the winter, ideally knocking the Soviets out of the war, was not accomplished. The United States then entered the war in December 1941, following the Japanese attack on Pearl Harbor. The war would now become one of attrition, in which the limitations of the German war economy were soon exposed. There were shortages of everything, and before long, the nuclear program was being stripped of its resources. The only hope was for the heavy water program in Norway, but this would have potentially taken decades to produce enough fissionable material for a nuclear weapon. Instead, Hitler ordered that any resources available for experimental weapons should be funneled towards alternative programs. These included the V-1 and V-2 rocket programs, seeing the development of the first ever long-range ballistic missiles created by any country. Heisenberg and his colleagues would have known, as the war went on, that they were engaged in a purely theoretical exercise. They would never have produced a working nuclear weapon before the war ended. The result of the Second World War really wasn't in any doubt from 1942 onwards. The Germans continued to fight a very serious conflict against the Soviets on the Eastern Front that coalesced around the Battle of Stalingrad. They lost this during the winter, and thereafter, the Russians began to slowly push them away from the Russian capital, Moscow, and towards others like Kyiv. In North Africa, a large invasion of Algeria and Morocco by the Western Allies in November 1942 would result in victory across the Maghreb in May 1943, followed swiftly by an invasion of Sicily and then southern Italy. 1944 saw a new Western Front opened in France, and in the spring of 1945, the Allies fanned out across Germany for the final acts of the war. In advance of this campaign into Germany, the Allies had established the Alsos mission to investigate exactly how much research the Germans had carried out in the development of a nuclear weapon during the war. Thus, as American, British, Canadian and French divisions occupied more and more German towns, they entered the universities and arrested physicists and other scientists. Heisenberg escaped detention for much of March and April. It was only in the final days of the war in early May 1945 that he was detained, He was sent to England in early July and questioned there. He expressed amazement when, just 4 weeks later, the United States dropped functional nuclear weapons on the cities of Hiroshima and Nagasaki in Japan. The Germans had been nowhere near being able to do anything of this kind. As he was questioned extensively over a period of weeks in Britain, Heisenberg retained the same line of defense. He had worked for the Nazi government to develop a source of nuclear energy, but had always tried to undermine any progress towards the development of a nuclear weapon of any kind. Studies of the transcripts of his interviews in 1945 and 1946 by physicists of the time corroborate the idea that Heisenberg had not been working on a nuclear weapon. If he had either made serious miscalculations or was a very, very convincing liar. The likelihood is that he was telling the truth. Beyond their heavy water program in Norway, the Nazi regime simply never committed the kind of manpower or resources that were needed to develop a nuclear weapon in any practical way. As the war wound down and the questioning in Germany ended, Heisenberg was released. There was little to charge him with, and the Allies had taken the view that only ideological hardliners involved with the Nazis, such as leaders of the regime and members of the SS paramilitary organization that administered the concentration camp system, would be prosecuted in a blanket manner. Unlike many other German physicists and scientists who were recruited by the American government and moved to the United States, Heisenberg chose to return to what would become West Germany, the parts of the country occupied by the British, French, and Americans after the war. He quickly re-obtained a position within the Max Planck Institute for Physics at Göttingen. The institute was moved to the city of Munich before long, however, and he would spend much of his later career in Bavaria. It was unusual that he took this decision. So many other German physicists, scientists, and engineers were now either in the United States or the Soviet Union. For instance, Werner von Braun, the rocketry expert who had developed the V-1 and V-2 rocket that rained down destruction on London in the final year of the war, had been more or less coerced into leaving Germany for the US. He went on to help the United States military develop its first ballistic missiles. In addition, von Braun subsequently became the most important individual involved in NASA's efforts to reach the moon before the Soviets, designing the Saturn V rockets that drove the Apollo space program. Heisenberg would never be tempted to go to America, and unlike von Braun, whose development of the V-2 rockets and use of slave labor in his factories had made it so he had little option but to do as he was told after the war, Heisenberg was free to choose his own career path. He would not have the kind of success which he had enjoyed back in the 1920s and 1930s. Still, he made his own contributions to science in the 1950s and 1960s, as West Germany sought to rebuild itself after the war. Heisenberg settled first in Göttingen, where he had taught and studied so many years earlier. There he undertook efforts to rejuvenate academic and scientific research in post-war Germany, even as the country was still under occupation. Much of this was about rehabilitating the country's institutions. For instance, Heisenberg was involved in the rebranding of the Kaiser Wilhelm Society, a body that had been established back in 1911 and which was compromised by its involvement in the Nazi nuclear research program. It was now renamed as the Max Planck Society. This new name was derived from the German Nobel laureate in physics Max Planck. Heisenberg served as an early chairman of the physics arm of the Max Planck Society. In this role, he promoted the idea that research into the sciences in Germany needed to adopt computing methods in the aftermath of the war. He also sat on several research councils in the late 1940s and into the 1950s. The primary goal of these was to allocate funding to aid the reconstruction of scientific departments within the universities of West Germany. The sector had been decimated by a brain drain to the US and Russia following World War II. There was also a perception issue to overcome. Heisenberg and his colleagues had to convince France, Britain, and the US that funding scientific research in West Germany would not lead to the creation of weapons that would be used against them in a Third World War. In light of this, Heisenberg actively promoted the idea during the 1950s that countries like West Germany, Britain, and France should share their research discoveries. In the post-war era, Heisenberg thus found himself working on the political side of academia. His work centered on the rejuvenation of the scientific community in a country which had been the world leader in physics and other disciplines for half a century between the 1880s and the 1930s. In addition, Heisenberg also found time to continue his own research work. An area in which he was especially interested during these years was the study of mesons. Mesons are hadronic subatomic particles, which are comprised of both quarks and antiquarks, fundamental particles that make up matter. Their existence had only first been theorized in 1934 by a Japanese physicist, Hideki Yukawa, who went on to win a Nobel Prize for his work in 1949. Heisenberg was one of many leading physicists worldwide who began studying mesons in greater detail in the post-war period. It was Heisenberg, for example, who broke new ground around the concept of isospin and mesons, how particles and quarks decay or are impacted as they interact with each other. He also became more interested in the history of physics and philosophy during this later period of his life, reflecting on his own position within the discipline that had transformed the world during his lifetime. In this vein, he traveled to other countries to give a series of lectures on these topics. These were subsequently written up and published in 1958 as Physics and Philosophy: The Revolution in Modern Science. Heisenberg was also searching for his own unifying theory of science in this late part of his career. For decades, European scientists and theoretical physicists in particular had been looking to find a unifying theory of physics which would tie together all of the discoveries made since the mid-19th century. In the process, such a theory would help explain the nature of life and the universe, the building blocks of existence. Einstein, for instance, had developed a unified field theory. This theory had attempted to tie all the particles and forces in the universe together into a single comprehensible field of connected forces. Theoretical physicists today continue to look for what is now termed the grand unified theory or theory of everything. However, such a comprehensive theory remains elusive. Heisenberg's contribution to this was his Weltformel, or world formula, which he hypothesized in 1958. Through his world formula, Heisenberg argued that all of physics, be it atoms, electrons, photons, the newly discovered mesons, or even particles and subatomic particles that physicists had not yet discovered, could all be defined as being part of a single elementary field of quantum mechanics. Heisenberg suggested that there were around 30 elementary particles, and that they were all interconnected. This was an irony to a physicist who had made his name primarily through the idea of an uncertainty principle, now proclaiming that there was a certainty about particles, some of which had not even been fully identified, as being interconnected. This being said, he was cautious about how he put forward the theory, repeatedly asserting that it was a theory, rather than something he was suggesting there was any comprehensive proof of. It caused a media stir at the time, and was followed quickly by an academic backlash. Many of Heisenberg's colleagues in West Germany and beyond rejected the world formula as lacking any substantive evidence to support it. Heisenberg's role in promoting what is known as the Göttingen Manifesto was more successful. Even before the Second World War had come to an end, The Allied powers were arguing amongst themselves about how Europe would be divided into different spheres of influence after the war. The Soviets, for example, won the argument that Poland would lay within their sphere of control in Eastern Europe, while the British Prime Minister Winston Churchill was compensated with a democratic Western-aligned Greece. Germany and Austria were very contentious. Eventually, Austria became a kind of neutral country in the Cold War, but Germany had been divided up into a Western-backed West Germany and a communist-dominated East Germany. As the Cold War heated up in the 1950s, a debate developed in both Washington and Moscow about placing tactical nuclear weapons in West and East Germany. This intensified after the testing of the first hydrogen bomb in 1952. The US took a leading role in promoting and funding the rearmament of West Germany, due to its frontline position against the USSR in Europe. Meanwhile, Heisenberg and 17 other leading scientists, including Born and Otto Hahn, joined together to issue a manifesto from Göttingen in April 1957. In this, they declared their opposition to the idea of US tactical nuclear weapons being set up in West Germany. The manifesto was short, though stark in its statements. For instance, the second point declared, "Today, a tactical nuclear weapon can destroy a small city, and a hydrogen bomb can render an entire region, such as the Ruhr Valley, uninhabitable. Already today, one can probably wipe out the entire population of West Germany with the radioactivity from H-bombs. We know of no technical means to protect a large population from this threat." Ultimately, their efforts were in vain. Through cloaked methods, the Americans and the Soviets had deployed thousands of nuclear warheads around both West and East Germany by the 1960s. By the 1960s, Heisenberg was no longer at the cutting edge of theoretical physics, nor did he seem to be trying to reclaim any such position. As a kind of elder statesman of the field, he toured the Western world, lecturing at Harvard in the United States for a while and giving guest lectures in other places. At home in Germany, he lived in Munich from 1958 onwards, after the Max Planck Institute for Physics was moved there from Göttingen. Entering the twilight of his life, his interest in philosophy grew, and he spent a lot of time considering Far Eastern spiritual systems, in addition to more modern European utilitarian and existential philosophy. His adherence to Lutheranism never faltered, however, and he was always able to incorporate his scientific work and his reading of other religious and philosophical systems into his core Christian beliefs. For Heisenberg, science could only ever explain the nature of the universe up to a certain point. He saw no contradiction in believing in God. After all, theoretical physicists during his lifetime might have identified more and more subatomic particles as the building blocks of the universe. However, nobody could explain why all of these building blocks came into existence in the first place. For Heisenberg, a religious truth had to lay behind this. This was one of the themes which Heisenberg explored in his autobiography, which he began working on in the mid-1960s. It was published in 1969 and translated into English 2 years later. Unusually, Heisenberg decided to write the book as a series of conversations about various topics, essentially harking back to the ancient Greek philosopher Plato's method of writing to present his own ideas and those of his mentor Socrates. The content was also different from a typical autobiography, and was more concerned with discussing the scientific and philosophical subjects which Heisenberg had been concerned with over the course of his career, than the actual events of his life in any linear sense. By the time it was translated and versions began appearing in other languages in the 1970s, Heisenberg's health was in decline. He was eventually diagnosed with kidney cancer, an ailment from which he died at 74 years of age on the 1st of February 1976. Heisenberg was laid to rest in Munich. Werner Heisenberg stands amongst the most important scientists of the 20th century. Born in Germany in 1901 into a family of Greek classicists, he developed an initial interest in physics while reading the works of the ancient Greek philosophers, many of whom were the world's earliest physicists and theorized the existence of atoms. In the aftermath of the First World War, he studied physics in Munich while Germany was tearing itself apart through economic collapse, violence and revolution, before gradually recovering from late 1923 onwards. By the time the country had entered into a period of Republican stability in the mid-1920s, Heisenberg, despite his youth, was already establishing himself as a physicist of immense ability. It was a fantastic time to be involved in this field, right at the birth of quantum mechanics. Heisenberg made his foremost contribution to science when he was just 25 years old, publishing his research and findings on the uncertainty principle. He accompanied this with his work on matrix mechanics and was one of the youngest participants at the famous Solvay Conference on Physics in Brussels in 1927. For this early work, in 1933, he was retroactively awarded the Nobel Prize in Physics for 1932, when he was just 31 years old, making him one of the youngest scientific Nobel laureates in history. A shadow was cast across his legacy in the years that followed as Heisenberg remained in Germany and played a role in the nuclear program run by the Nazis prior to and during the Second World War. Heisenberg, it must be said, was not as complicit with the Nazi regime as other German scientists had been. Werner von Braun, for example, engaged fully in the Nazis' development of the V-1 and V-2 rocket programs, and was later taken to America to play a crucial role at NASA as space exploration entered its infancy. Unlike von Braun, Heisenberg was largely just a German scientist caught up in a German war effort. Nevertheless, how firmly he was committed to Nazism at the height of the Third Reich in 1940 and 1941 remains a controversial issue. After the war, he tried to redeem himself. He unsuccessfully campaigned to ensure that West Germany remained a nuclear weapon-free zone, while he also became more interested in philosophy and the history of physics. The days of his immense breakthroughs, like those he had made back in the 1920s, were behind him. Nobody can deny, though, regardless of his wartime record or his early peak as a researcher, that Werner Heisenberg was one of history's great theoretical physicists and a founding father of the field of quantum mechanics. What do you think of Werner Heisenberg? Was he one of the greatest scientists of the 20th century? Or is his legacy tarnished because of his associations with the Nazis? Please let us know in the comment section. And in the meantime, thank you very much for watching.